All right. So they put the parentheses in there mostly, I think, to confuse us, but really it's to show us that we have one complex number plus another complex number. So they're really just sort of highlighting adding two things together. But really, for most of us, it just is a little confusing. Okay. We are simply adding things together, combining like terms. I don't really need these parentheses since it's just an addition problem. -1 minus 2i plus 3 plus 7i. With or without those parentheses, it says the same exact thing, and all we need to do is combine like terms. So I'm going to look for my regular old numbers. -1 and a positive 3 gives me 2. And then -2i and positive 7i gives me, yeah, positive 5i. This is the real part. This is the imaginary part. And when we put them together, we get a complex number. Two plus 5i is the answer. Nice, right? Okay. B is slightly more challenging. What makes it slightly more challenging? There's a little bit, yeah, there's an extra thing hanging on there, but really, there's one thing that messes everything up. What is it? It's subtracting. Subtracting is always a problem. We have to subtract this entire complex number, which means we really need to distribute, distribute, distribute a -1. So when you're subtracting, you need to make sure that you distribute your negative, okay? To make sure that we're subtracting all of it. Nothing in front of this one, that's just 4 plus I. But I do need to distribute my -1. -1 times 2 is -2. -1 times -5i becomes positive 5i. We do have this extra thing added onto the end. Sure, I can add the 2i onto the end. Addition is easy. Subtraction messes everything up. So be very, very careful when you see that subtraction sign. And now, again, we can just combine all of our like terms. So we have 4 and a -2, which gives me what? 2. And then we have a positive 1i. Notice I put the 1 in there. Positive 1i plus 5i plus 2i, which gives me 8i. So positive 8i's. Real plus imaginary part makes a complex number. Okay, it's easy, right? It's nice, right? A nice Monday. Any questions so far? All right, what are we doing now? Distributing. Yeah, right now we are multiplying. Multiply means we need to distribute. distribute. I don't know what my problem with distribute is today. We are distributing or multiplying. And so here, I want to remember, what is I squared equal to? -1, yes. I squared is equal to -1. That's going to be really important here when we're multiplying, okay? So I'm going to go ahead and distribute. Right now I'm distributing my -I. What is -I times 3? -3i. And what's -I times I? What's x times x? X squared. What's I times I? Very good. So I times I is I squared. You can think about it as I to the first times I to the first is I to the second, okay, adding those exponents. So negative I times I would be negative I squared. Now, your solution should never have I squared in it, okay? So if you see I squared, you have to simplify I squared. And replace I squared with what? What can I replace I squared with? Negative 1. I squared is equal to negative 1. So anytime I see an I squared, it's going to convert into a negative 1. That becomes minus a negative 1. What happens to that? Yeah, so negative 3i. Negative times negative turns to a positive 1. This is a great answer. Is it in standard form? A plus bi, is it in standard form? Not really. So if I could change it around, the a is 1, and the I imaginary part is a negative 3i. So either of these two answers is fine for me, but they're equivalent answers. Positive 1, negative 3i. Okay. All right. What do we need to do on letter D? Distribute. Sure, we got to distribute. So we're going to multiply that 2. All right. 2 times negative 6 is negative 12. Good. 2 times negative 2i is negative 4i. I need to distribute my 3i. 3i times negative 6 is negative 18i. Good. And 3i times negative 2i is negative 6i squared. Very good. So 3 times negative 2 is negative 6. And I times I is I squared. Now what do you notice? What else can we do? Combine like terms? Sure. We've got a negative 4i and a negative 18i. Can definitely do that. So I have a negative 12. Negative 4i and negative 18i is negative 22i's. What else? The I squared. We have an I squared. We can never see that. So what are we going to replace the I squared with? Yeah. So it becomes negative 6 times negative 1. What happens to that number? It becomes positive. Yeah. So we have negative 12 minus 22i plus 6. So negative 6 times negative 1 changes that to a positive 6. And then we just need to combine like terms one more time. So negative 12 and positive 6 give me negative 6 minus 22i. And there's a great answer. Questions on those? Good? It's pretty easy, right? Okay, nice. Nice Monday. All right, 2 more. All right. Just want to point out that with all those sides, I've been talking for 9 minutes and 29 seconds. So you shouldn't be sighing. When I was in school, they taught all 55 minutes. Bell to bell, teaching, lecturing. All right, so we did some adding and subtracting. The last 2 problems were multiplying. What are we doing here? Dividing. These are quotients. When we are dividing, so first of all, let's remember, what is I equivalent to? square root of -1, okay? So I is equivalent to the square root of -1. Then what I have here, 3 minus the square root of -1 is not allowed. Why isn't that allowed? We can't have square roots in the denominator, okay? So we have to rationalize. And we have a very special way that we're going to rationalize to get rid of that square root in the denominator. So you need to write this down. Multiply by the conjugate. Multiply by, write that down. Conjugate, like to conjugate a verb, it's changed just a little bit of it, and it changes the meaning, okay? Well, right here we have 3 minus I. That is a binomial. There's 2 terms there, 3 and then a -I, so 2 things. Whenever we have a binomial, that one thing that we can do is multiply by the conjugate. Have we done this before with radicals? Did we do this? I don't remember. Yeah? Okay. We should have. So, let's see.
We did.
Okay, the conjugate changes one sign. So I have 3 minus I. We're going to multiply top and bottom by, change one sign. What does it change into? Change the negative to a positive. What am I going to multiply by? 3 plus I on top and bottom. So what I'm doing is I'm multiplying by the same thing on top and bottom. So effectively I'm multiplying by 1. And that's not going to change what I started with, but it cleans up really nicely. So we are going to go ahead and work for a minute just the numerator. What do I need to do if we just have the numerator there? Distribute, sure. All right, what's 7i times 3? 21i. And what's 7i times I? Plus 7i squared. Very good. And what do we need to clean up with that? I squared. Very good. So instead of I squared, what is it really? -1. So I'm just going to write that above just to save myself a step here. I squared is really -1. So I'm multiplying 7 times -1. So I have 21i. What happens with my 7 times -1? What does it change into? -7. Positive 7 times -1 is -7. Okay? Not too bad. In the denominator, we have to FOIL that out. So my denominator, ignoring the numerator here, I have 3 times 3 is 9. Got to distribute my 3, so 3 times I gives me positive 3i. And I need to distribute my -I, so distributing that -I as well. -I times 3, -3i. And then -I times positive I, -I squared. -I times positive I is -I squared. What happens in the denominator? Positive 3i and negative 3i. What happens with those? They disappear. 0. That's really handy. And then we're left with the 9. And what do we have to do with the I squared? What is I squared? -1. So it's 9 minus a -1. Negative times -1 is +1. Negative times negative turns to the positive. So we get 21i minus 7 over 9 plus 1 is 10. The very, very, very last thing I want you to do is break apart the 10. This 10 divides both terms above. So I want you to separate, divide, and conquer, really. So split it apart and write it so that that 10 divides both pieces. This one doesn't reduce, but if you did that, you see you've got some fractions. So you might be able to reduce those fractions. And that's our answer. You'll notice there are no more i's in the denominator. That was our goal, to get rid of the i's in the denominator. Last one, 2 minus 7i over 1 plus 3i. Should have chose different numbers, but you know. 2 minus 7i over 1 plus 3i. What should I multiply by? What am I going to do? Hey, good job using the words. Multiply by the conjugate. That's how you wrote that down. Okay. What is the conjugate going to be? Yeah, 1 minus 3i. Change the sign. Change one sign. That's all you have to do, and that's the conjugate. 1 minus 3i on top and bottom is allowed. We're going to go ahead and distribute. I'm just going to worry about the numerator first. And distribute my 2. 2 times 1 is 2. 2 times negative 3i, negative 6i. I'm going to distribute my negative 7i. Negative 7i times 1, negative 7i. And negative 7i times negative 3i becomes positive 21i squared. 7 times 3 is 21. I times I is I squared. I'm going to do a little bit of cleanup. My negative 6i and negative 7i I can combine. And what's I squared equal to? Negative 1. So I'm going to change that as well. So I have a 2, I have a negative 13i, and this becomes 21 times negative 1, which is negative 21. And then I can do 2 minus 21 is negative 19, and a negative 13i for the numerator. The denominator is the easy part. I'm going to distribute my 1. 1 times 1 is 1. 1 times negative 3i, negative 3i. Then I'm going to distribute my 3i. 3i times 1, positive 3i. And 3i times negative 3i, negative 9i squared. Very good. So again, what happens with my inner little in-between terms? Gone. Negative 3i and positive 3i is 0. And then I squared is really negative 1. So this becomes 1. Negative 9 times negative 1 becomes positive 9. This happens to be over 10 again. No more i's in that denominator. And then I just need to divide and conquer. Split up that 10 so it divides each part. And again, you can reduce the fractions once you get to this point, if possible. Reduce the fractions if possible. These don't reduce, but there are some in your homework that reduce, okay? Knowing that 10 divides both things is huge. The next step we're going to learn. All right, do you have questions for me? All right, ladies and gentlemen, you have the last practice 51.